Hello, everyone. I'm Darren from NovaStar. And long time no see, I'm coming back again. So welcome to our NCE training. I believe we have some old friends in the chat, in the Zoom meeting, and also there are some new friends here. So I'd like to start with a brief introduction of NCE training to the guys who are not much familiar. So the full name of NCE is NovaStar Certified Engineer. So we have trained more than 4,000 individuals all over the world since it started from 2014. So by giving multiple courses and valuable chances to embrace the LED control system, NCE courses enable you to operate and maintain the equipment independently. So we are hoping the more techniques could get knowledge and the certification. Yes. This term, we will have 5 courses. And you could get a professional certification if you sign in for 3 courses at least and pass the final exam. And please note here, only the sign during the Zoom meeting period is qualified. So this is very important. And I hope all you guys can participate all the courses, not only because you can get a good grade, but also because we have added something new to this year's training. So let's have a look. So today we're going to talk about the basic structure or basic knowledge of Nova control system. And on tomorrow is Tuesday, we're going to talk about the basic configuration of Nova LCT. So we also have some demo of the practical part. And on Wednesday, we will talk about the H series introduction. And on Thursday, we will talk about cloud-based platform. And on Friday, it's our all-new MX series solutions. So except the training content, this year we also made some new changes. As you can see now, I'm standing on the podium of a school because in the past 2 years, we have not only focused on the research and development of new technologies and products, but also we cooperate with many colleges and universities in China to cultivate more excellent technique talents for the whole LED industry. Okay, today, we are going to spend an hour and a half together to talk about the basic knowledge of Nova control system. So you will learn about, please note here, in the Zoom meeting, you may have 2 views. On the left side, there is your slide view, and on the right side is a camera view. So if you cannot see the PowerPoint clearly, you can check the left view. And if you want to see my presentation, you can check the right view. So today we're gonna talk about the system structure of the LED control system and the introduction of NovaStar product lines. And more importantly, you will have a better understanding of a product selection for different scenarios. And in the last, we will talk about the fiber solution. So first of all, I would like to warmly welcome Dr. Qiu Shanshan from the Nanjing Vocational College of Information Technology to explain the basic structure of the LED control system. Dr. Qiu.
Okay, thanks for Darren. Hello, everyone. It's my great honor to have this opportunity to communicate with all of you. As we know, NovaStar is a company that develops the LED control systems. So first thing we need to know is what is the LED control system. I believe some of you may not be very clear about what makes up the LED cabinet, which you work with every day. So let's see the LED module first. LED module is the smallest unit in the LED cabinet. One cabinet is composed of multiple LED modules. Here is a photo of one module, the front side and the back side. If we take a close look, we can easily find out the module structure. It consists of the PCB. We usually call it printed circuit board, power supply connector, ICs, including driver IC and decoding IC. The driver IC is used for control the LED lamps from the vertical way, and the decoding IC is used for control the LED lamps from the horizontal way. And they work together under the command of the LED control system realize the function of light or off and shows different images on the LED screens. Besides, we can also find there are hub connectors on it, which is used for connecting to the receiving card via a flat cable. And normally we use the hub 75 type, which means there are two RGB date groups on this module. As we know, there are different kinds of LED modules from different manufacturers. So here I divided them into three different types of LED module: DIP, SMD, and COB. The DIP was very common many years ago. It is a classic package method. DIP usually have big pixel pitch and may be used for outdoor. SMD is the most common package method nowadays, no matter for outdoor or indoor. COB means chip one bird. It is the latest technology. It could reach much more smaller pixel pitch, like 0.7 millimeters, something like that. So it's kind of technology made up with the request of the future of LED industry. This is the difference between SMD and the COB package. Okay, after the LED module, now we need to create a LED cabinet. LED cabinet consists of several modules arranged according to certain rules. And there is a receiving card and a hub inside the cabinet, connected to LED module through the flat cable. The hub card is not necessary all the time. If you use the receiving card, which integrates the hub connection itself, then you can connect the LED module to the receiving card directly, such as receiving card MRV 366. Here is the cabinet items list, which includes the cabinet frame, the LED module, receiving card, hub, power supply, and cables. Normally, there is only one receiving card inside each cabinet, but the pixel pitch is becoming smaller, so the resolution of each cabinet becomes bigger. Sometimes one receiving card is not enough. In this case, one cabinet may have two receiving cards inside. In another word, it will be regarded as two cabinets in LED control system. Okay, as we just mentioned, LED cabinet is composed of many LED modules. Then the LED screen is composed of many LED cabinets in the same principle. So as the picture shows, for the LED screen, it consists of several cabinets. Okay, now let's have a look back about the module cabinet screen relationship from the control view. LED screen consists of several LED cabinets. LED cabinets consist of several LED modules, just like this. Now, we know how to set up the LED screen. If we want to show image on the screen, then we need to set up the control system. Here, we can see the control computer is connected to the sending card through a USB cable or an Ethernet cable. Then we can send control command to the sending controller. And we also use a HDMI or DVI or DP cable to connect with the sending controller. Then the PC can provide video source to the sending controller. Then the sending controller is connected to the LED screen wall through Ethernet cables from different ports. And the information can be displayed on the LED screen. This is the basic structure of the entire LED control system. But please note here, the video source resolution exactly same as the LED screen resolution. What if it is different? Well, mostly source resolution is different with screen resolution. Here we can see the video source resolution is 1366 by 768, while the screen resolution is 700 by 500. The video source resolution is bigger than the LED screen resolution, so the screen can only show part of the image. Since the sending controller do not have the ability to scale the video resource, if you want to display all the content on the screen, a video processor or software scaling is necessary, which can scale images resolution to 700 by 500. Now the system structure will be like this. The video processor comes from the PC, goes to the video processor first. Then the video processor will deal with the video source before providing it to the sending card, such as scaling. System structure becomes more collective, become more complicated, right? So what's the solution for this? The all-in-one controller come out. The system will be simplified again as a beginning structure. All-in-one can do the job of a standing controller and a video processor at the same time. Okay, we just have a short view about the LED control system. Next, I will pass time to Darren. He will show you about NovaStar product line and product selection in different application scenarios. Thank you.
Okay, thank you, Dr. Chu. We just know about the basic structure of the LED control system from the basic unit, like the LED modules, into the LED cabinets, then to the LED screen. And the video source will be provided from the, normally it's provided from the control PC, and it will be transmitted to the LED screen via a sending controller. And you can, as you can see here, if you want to realize some basic video processing functions, we need to use all-in-one controller, right? Or we need to add a video processor. Okay, now let's have a short review about NovaStar product line. Now we have 4 product lines: the LED control system, the cloud-based platform, the calibration system, and the video product. For the LED control system, we now have 2 branches. One is an independent controller, and another is an all-in-one controller. Maybe some of you are familiar with the independent controller, the M control series, such as MCTRL 300, 600, 660, R5, okay, right? Why we call it independent controller? Because they do not have any video processing functions. They're just a pure sending card. Okay, for the all-in-one controller, we also have 2 branches, one in the VX series and the Nova Pro series, and we will talk about this later. For the cloud-based platform, it's quite different for the basic LED control system. Sometimes we also call it asynchronous control system. So we have the hardware part, the NovaStar series. We will talk about this part on Thursday's course. And also we have the remote publish system, which is Vinox platform. And this year, we also released some new remote monitoring system. We call it Vinox Care. And this part we will talk about detailedly in Thursday's course, okay? And another very important product line is calibration system. As you can see here, we have the normal calibration and the calories calibration. For the market, as we know, many years ago, there's a DIP package, and now mainly the SMD package. Because the pixel pitches become smaller and smaller, and the COB package is more popular. So for the normal calibration, like the SMD, we can just use a digital camera. We will collect the parameters, will generate the coefficients for the LED screen to improve the color, the brightness of the LED screen. But for the fine pitch project, like the COB or mini LED or macro light, we need to use a calories calibration, which we will use the industrial camera. And we also have a specific courses for this part when the offline training can be held. And the last product line is about the video product. As you can see, some of you may familiar with some of this product, like the G6 is a video slicer, and the N9 is a video switcher, and C1 is a cathode. It's mainly used for the rental project. And the HDR Master 4K is a video processor that we can enhance the HDR effect to HDR effect. So basically, this is a full product lines from the LED control system, calibration platform, cloud-based platform, calibration system, and a video product. And today we will mainly talk about the LED control system. Okay, now let's have a short review about the history of the product evolution. Then we can know the logic behind all the product evolution. So let's take a look about the family photo. So here, I believe some of you may know some old frames, right? This one, M Control 300, 2 ports, 1.3 million pixel loading capacity. And this one, M Control 600. So from the 300 to 600, the ports, the loading capacity from 1.3 million pixels increased to 2.3 million pixels. And from the 600 to 660, what's the difference between these two models? From the parents, as we can see here, there is only a switch button, a power on, power off, right? But on M Control 660, we add a small LCD monitor and a wheel button. So we can realize some quick configuration with a LCD monitor and the wheel button. And also we released a new model named the M Control 700 and M Control 660 Pro. So later we will also talk about these two. What is the difference between the M Control 600 to the 700, and also what's the difference between the 660 Pro to the 660. And when the pixel pitch becomes smaller and smaller, the screen resolution has become bigger and bigger. So this product is not enough. The loading capacity is not enough. 1.3 million pixel, 2.3, 2.3, 2.3, 2.3 million pixels is not enough to hold a screen over like 1080p or Full HD, right? So we released some models which have bigger capacities, like M Control R5. It supports to load a 4K by 1K resolution screen. And if we have a 4K project, then we can use an M Control 4K. So this is a family photo about the independent controller. Okay. Now let's think about it. So from the original one, so we covered M Control 300. There is also another model named the MSD 300, which is without this box is a card. So from the M Control 300 to the M Control 4K. So what is the logic behind this? I divide them to 3 like evolution lines. The first, let's take a look. The input source type. So for example, in M Control 300, we have only DVI source input, single link DVI. So if we want to load the screen, I need to provide a DVI input, or I need to switch the HDMI to DVI, then I can connect to the M Control 300. This is the original input source. But on the M Control 600 or 660, we also add the HDMI interface on that module. And we also have some DP and SDI on M Control 4K and M Control R5. So this is the product evolution lines. The input source become more. From the single link DVI, we have more video source input supported. And the second one, I believe, is the loading capacity, right? For 2 output ports, okay, there is a very important information. For each output ports, it supports loading 650,000 pixels, which if you check the specification of all NovaStar products, each port, it supports 650,000 pixels. This is very important when you design a project. And tomorrow's course, Deacon will tell you why we get this number. But today we only talk about the product part. Okay, so with 2 output ports, then we get 1.3 million pixels, right? Okay, with 4 output ports, it's 2.3 million pixels, 2.3. And with 8 ports, it's 4.1 megapixels. And with 16 ports, we got 8.8 megapixels. But if you check these numbers, if you multiply like the 615 pixels by 4 parts, it should be 2.6, not 2.3, right? Actually, there is some limitation because the video source input. But tomorrow, Deacon will give you a detailed explanation about this part. So you just need to know for the independent controllers, the loading capacity is not determined by how many outputs you have. It's related to the video source input. So this is very important. So for example, uncontrolled 4K support loading 880 megapixels. The reason is because it supports, here I'll give you it supports 4K resolution, right? 640 19.6 by 2160. So if you get this resolution, it will be 808 megapixels here. So let's have a summary. For the independent controllers, the loading capacity is not just determined by how many outputs you have. It's related to the video source input. This is very important. All right, let's move on. And the third evolution lines we just mentioned is the LCD panel and the knob. So here I divided them into two different camps. For example, the amp control 600, 300, 600, and 700, they all do not have the LCD panel and the wheel button. So if we want to configure the screen, we need to connect the control PC, and we need to install the NovaStar software on the control PC. Then we can realize to configure the screen. If we use amp control 660 and 660 Pro or R5 4K, we can use the LCD monitor and the wheel button. We can realize quick configuration on the screen. Can you hear me? All good? Okay, can everybody hear me? If you can hear me, you can just tap 1 in the chat room, and the host will give me this information. All good? Okay, thank you. So I will have a short review here. So with different resolution, we have different product to use, right? If we have a screen which the resolution is smaller than 1.3 megapixels, we can just use the amp control 300. That's enough. And if we have a screen which resolution within the Full HD, we can choose 600, 660, or 700, or 660 Pro. Okay, what is the difference here, right? 600 and 700. 600 we have 4 output ports, and 700 we have like 6 output ports, right? But they all have the 2.3 megapixels that I just mentioned. It's not related about output ports, it's about the video source input. They all use the single link DVI. The single link DVI maximum resolution is 920 by 1200. So that resolution is 2.3 megapixels. So that's why 600 or 700, 660 or 660 Pro, they all support 2.3 megapixels. So with this kind of project, this product you all can use. And if the screen resolution become much bigger, then we can choose the amp control R5. It supports the 4K 1K resolution, okay? And if we meet a real 4K project, then we can just to select the amp control 4K. Okay, now let's take a look. The question here. So I just mentioned amp control 660 and amp control 700 and 660 Pro, 4 output ports. Here, 6 output ports. So why 6 output ports still carries 2.3 megapixels, as already explained in the last page. But here is a question, why we need to use amp control 700, right? If we have a screen, the resolution is Full HD, you can use 600 is enough, but why NovaStar you still release a new product named AMP Control 700? Have ever have this kind of dot? Okay, let's have a real case together. This one is a real case. Here is a project. The screen resolution is 1920 by 1080. It's a standard 1080p, right? So the cabinet resolution is 384 by 216. So please recommend a proper sending controller for this project. The system structure should be as simple as possible. So I will give you like around 2 minutes. You can think about this project and you can give your answer to the chat room. 2 minutes. Check this. Screen resolution 1080p and the cabinet resolution 384 by 216. So what is the best choice for this project? If you have the answer, you can just tap your answer to the chat room and I will check with the host. Think about it. The screen is 5 columns and 5 rows. Okay. Okay, I saw a solution for AMP Control 600. Okay. We also have a 660 Pro or 700. Okay. Any other recommend models for this project? Okay, a new one. 600, 660 Pro, 6060, 700. Okay. Okay, let's talk about this, right? I saw the answer. So now we have this answer, 600, 660. Right? Some of you choose this two modes. And also I saw this model, 700 and the 660 Pro. So what's the difference between this? I've already explained. This we have 4 output ports. This we have 6 output ports. So the first step, we need to calculate the total resolution of the screen, right? If we multiply the 9020 by 1080, you will know the resolution is within 2.3 million. So seems like the 600 or 600 Pro or 700, 660 Pro, we all can use to this project, but actually no. Why? The reason why? It is because for the 600, AMP Control 600 and 660, we only have 4 output ports. But for the LED control system, when we're doing the screen mapping, for example, it will it will calculate the loading capacity by rectangular area. So with the 4 output ports, you need to make sure each output ports, the connection way cannot exist the loading capacity of 650 megapixels, right? So if we use this one, it's not enough. You can take a quick calculation. You can take a quick calculation. The AMP Control 660, we use 4 output ports. For example, if we like this one, how many cabinets we can load for each output ports? Please give your answer to the chat room. For 1 output ports, how many? This is the cabinet resolution. For 1 output ports, how many we can load? Do we have answer? Anyone How many? For this cabinet resolution, how many cabinets I can load for one output ports? You can just type your answer to the chat room, and I can see from here. No answers? How to calculate? Okay, it's 150,000 pixels divide 384 and 10. So this is how many pixels? Yeah, I saw the answer. Should be 7, right? 7 cabinets. So, okay, let's have a. So if we connect to the screen like this, 1, 2, 3, 4, 5, 6, 7, port 1, right? Port 1. Okay, port 2. 1, 2, 3, 4, 5, 6, 7. Port 3. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, here. Port 3. And port 4. 1, 2, 3, 4. So seems it's not overloading, right? But I just mentioned when the system calculates the loading capacity, it will be check the rectangle area. So the port 1, the rectangle area is like this. Oh, I changed a different color. Sorry. So the port 1, it will be calculate light totally 10 cabinets. So it's overloading. It's overloading. So the same principles for port 2, port 3. Only the port 4 is not overloading because in this rectangle area is only 4 output ports. So that is the reason why. That is the reason why the 600 and 660 cannot use for this project, because we cannot divide the cabinet to exactly equal to for the 4 output ports. Then we need to use the 700 or 660 Pro, which have 6 output ports. So I might explain well about these parts. Okay. So we just talked about the independent controllers. So what if we have some new requirements about the project? For example, the screen resolution, right? Screen resolution is 1920 by 1080. It's like the 1080p screen, but the video source, I just use a computer which the graphics card output capacity is not that good. So the video source resolution is 1366 by 768. So which means the video source resolution does not match the video source screen. We need to use the scaling function. But with the independent controller, I just mentioned there are no video processing functions. We need to use the all-in-one controller. So the difference between the independent controller and the all-in-one controller, we just combine the sending part and the video processing part together, and we call it all-in-one. Okay, here is a family photo about the all-in-one controller. The first one, the Nova Pro HD, which is the first all-in-one controller of NovaStar. It has, it also supports 2.3 megapixels with 4 output ports, but it also has a DMX port and also support the web page control, which is for some rental project. With the VXOS, also for output ports, but without web page control and without the DMX interface. And recently, we just released the VX600 and VX1000, and later we will talk about this detailedly. And for the 4K resolution, all-in-one controller, we have the Nova Pro UH Junior. So basically, if you check this interface, you will find we have basically 2 branches: the Nova Pro series and the VX series. And the same principles, we can also find the logic behind the product evolution. The first is the loading capacity. So for the output ports, like 4 output ports, is 2.3 megapixels. And for 6 output ports, now is not about the 2.3 megapixels. Now it's 3.9 megapixels. So if you calculate the total loading capacity, it should be 650,000 pixels multiply 6 ports. So you will get the resolution. The loading capacity is 3.9 megapixels. And same principles with VX1000, we have 10 output ports. So the total loading capacity of this model is 6.5 megapixels. And with the 4K resolution project, the Nova Pro Junior, we have 16 output ports. So the total loading capacity should be 650,000 pixels multiplied 16 is 10.4 megapixels. So for the all-in-one controller, we also meet the requirement of the market from the 1080p level to the 4K 1K level, then to the 4K 2K level. And if we have much bigger resolution, for example, it's over 4K, even reach to 8K, what can we do? Since NovaStar does not have this kind of product, right? No, it's not like that. We have the H series. We will talk about H series on Wednesday. Okay, here I also divide them into VX series and Nova Pro series. So if we have a screen which resolution is within 2.3 megapixels, we can just select the VX4S or the Nova Pro HD. And if we have a screen resolution which within 3.9 megapixels, we can just choose the VX600. And for the VX1000, it supports 3.5 megapixels, which is much bigger than the 4K 1K resolution. And if we have the 4K screen, we can just use the Nova Pro Junior. For some of the market, we also have the VX16S. It's also a 4K all-in-one. Okay, now let's see them one by one. For the VX4S, the basic one, we have let's see about the input part. We have the DP 1.1, HDMI 1.3, single link DVI, and the video source input, and we also have a 3G SDI, CVBS, and also audio input. It has 4 output ports, and you can see here 4 output ports, and also a DVI monitor. Here we can connect to a LCD to check what's going on about the output, and we also have a DVI loop. So here it's a DVI input, it's a DVI loop. DVI loop is mainly used for the mosaic function. We will talk about this part in the 4K solution. I will give you a detailed explain. And for the loading capacity for VX4S is 2.3 megapixels. And here is also very important when you design a project. The maximum output, you should see here, the max width is within 3840. So which means if we have a screen, the resolution, the width, if it's over 3840, the VX4S is not recommended for this project. And the max head is 9020. So you need to check the screen width and height before you select this module on this project. And the max layers, there's a very important feature about the all-in-one controller. For example, I just mentioned for all-in-one controller, we can all do the basic scaling function, but it is not just the only feature. We also can open several layers, or you can call it windows. So for VX4S, we can only open 2 layers, but this is the picture-in-picture. So there is always a main source and always the PIP source on its main source. It's not the free free pattern. So you can always open the main source and the PIP source on the main source. And with the presets, we support 10 presets, which means we can set 10 presets and save it in the VxOS. When we have a project or we have an event, we can directly switch the preset 1, preset 2, preset 3 for different applications. And also here, the quick configuration is because we have a small LCD monitor and a wheel button. So we can press the wheel button and with a knob, and we can do the quick configuration to map the screen. And also we can quick switch the video source from the front panel. Here is a video source input. I can directly press the DVI and press HDMI. The video source from the LED screen will be changed. So this is about the features about VxOS. Let's see the VX600. The input of VX600, we have the HDMI, single link DVI, and 3G SDI. And here, I just mark it in white color. We also have 2 optic fiber ports that can be used for input, but this is only used for NovaStar project like N9. So we can, the output from N9 we can provide to the VX6S. It can be as a video set, can be one of the video source to the VX600. This is mainly used for some rental project. For output part, we have 6 output ports. And also here, the optical fiber can also be the output. If you use this with an N9 switcher, it can be the video source input. If we use this for output the signal to a fiber converter, it can also be output ports. And also here we have a HDMI monitor, and the HDMI, DVI, and SDI, we all have a loop signal. For the loading capacities, we have 3.9 million pixels. And then the maximum output, the max width and height is become much bigger. So here we can see the max width of the VX600 is 240. So which means if we have a super long screen, as long as the width is within this number, then we can use the VxOS. But here, please note, the max width and max height is not reached at the same time. So if you reach the 10 to 40, then how many pixels you can load on the height? We need to use the loading capacities divide the max width. You can get the number how many pixels we can load in the height. So this is also very important when we did that project. Okay, for the VX6S, we have 3 layers, and all these layers is freely. You can put it like left, middle, right, or top, middle, bottom. It's all free as long as you want to put it anywhere. And also here we have 10 presets. And the very important part is the features of VX6S. It's quite different with the previous VxOS. For example, it supports the bypass mode. What is a bypass mode? It's very important because for the independent controllers, it have latencies for it's like one frame. But if we use all-in-one controllers, normally we have 2 more frames, like three frames. If we use the bypass mode, it will just disable the video processing part. So it can also work like the independent controllers if we just enable the bypass mode. So, and also we can enable the low latency on this mode. And for the fiber convert mode, this can be a sending controller at the same time. It can be a fiber converter. So if we have a project to which the screen distance is far from the control room, we can use 2 pieces of the VX600. One for the control room to be the sending controller mode, another close to the screen to be the fiber converter. And the OPT auto fit is about the input and output. If you work with the N9 switcher, it can be the video source input. If we work with the outputs, it can be the output port. And let's check about the VX1000. So if you check this interface, basically the they have some common features with the VX6S. The only difference is the loading capacity is much bigger than 600. It has 10 output ports, support 6.5 megapixels. And the other features is basically same with the 600. So it just depends on the screen resolution. If we have much bigger one, we can choose a VX1000. If it's not that big, we can choose a VX600. Okay, when we reach the 4K project, then we need to use the Nova Pro UH Junior. The loading capacity is become 10.4 megapixels. And here, the maximum outputs, the width and height is even bigger. 16384 and 8192 in height. So if we have the project, which is not a normal resolution, we need to check whether it's within this max width and height. If it's okay, then you can use the Nova Pro UH Junior in your project. And here is a feature about Nova Pro UH Junior is a DVI mosaic. Because here you can see it have 4 single link DVI. So the DVI mosaic can slice this 4 video DVI input as one independent video source. And we can just select the DVI mosaic source at the front panel. This is a feature of the Nova Pro UH Junior. And also it supports the 3D project, the had dynamic range project, and also it supports enable the low latency mode. And same with the VX600 and 1000, it supports the fiber converter mode. You can put one with the Sony controller, and another with the fiber converter. And also for the Nova Pro UH Junior, the optical fiber output ports is just for output. It's just for output. But the output, we have two modes. One, there are two pairs of the output ports. It can be duplicate, and also you can switch it to like backup mode. It depends on the requirements we are on site. Okay, now let's have a short review. This is a chart comparison from the VXOS to the Nova Pro UH Junior. So you can just take a screenshot, or you can take a picture about this interface. I think on the slide set, you can just take a screenshot. Okay. Now we need to talk about the product selection for different scenarios. As we know, for the market, the LED screen has become more and more really common for different projects. For example, the 4K solutions, right? For this industry, we define the 4K solution with two resolutions. Sometimes we call it like 3840 by 2160. Sometimes we call it 1496 by 2160. So actually, in the LED industry, we can both use these two resolutions to represent 4K. If we talk about the 3840 by 2160, we can also call it Ultra HD, which is UHD. Okay, let's see the traditional solutions for this 4K project. Here, I use AMP Control 660 as a model. AMP Control 660, the loading capacity is 2.3 megapixels, right? So each controller, we can load a 1080p resolution screen. So if we map a 4K resolution screen, we need at least 4 pieces of it. For the video, for the image, if we want to display the whole image, we must need a video slicer in the front and also a 4K video slicer. So the video source will provide to the video 4K video slicer, and it will provide to the first, second, third, and the fourth one. And they will slice the content, the image, to a complete image on the screen. So this is a traditional way. So we have the control PC, the video slicer, and we have 4 pieces Sony controller. Okay, so if we want to, if we want to do it another way, for example, if we use an all-in-one controller, what is the structure? It will be like this. No need to use a video slicer. the control PC provides the video signal to the first. For example, here is a VXOS, and we use the DVI loop to the second one, to the third one, and to the fourth one. And we can use a mosaic function to do the configuration on each VXOS. So it will know, I will call the video source in 4 parts, and the first VXOS will display the top left, and the second one maybe the top right or bottom right. So 4 pieces VXOS, we can also use a mosaic function to finish the 4K resolution. But what is the disadvantages? Here, as you can see, as we know, for the video source input, VXOS only support 1080p level, such as the HDMI 1.3, right, or ThinkBlink DVI. So if there is a 4K video source input, it cannot fit to the VXOS. So for this project, the video source it must like a full HD level, and it will be stretched to the 4K resolution. So the image quality may be not that good because it's not pixel by pixel. But the advantages compared with the traditional way is we do not have a video slicer here, so the system structure will be much simplified. Okay. So this is the real picture. If you go to the control room, all messed up, headache, right? And what can we do? We can just use a much bigger resolution, much bigger capacities models to solve this problem. For example, we can add a video processors and provide the video source to the M control 4K. The 4K can hold a 4K resolution screens. And maybe you are wondering why we need a video processor here. We can switch the video source input quickly by press a button in the front panel. And also we can open several layers on the screen, right? To realize like different presets on the screen. This is about the video processor and the independent controller way. So if we want to simplify it much, we can use the all-in-one controller. So here, the video source directly goes to the Nova Pro UHD Junior, and we can directly load the 4K screens. And we can also quick switch the video source input in the front panel, and it support open layers on the front panel. So the system structure become much simplified. Oh, we just talked about the 4K solutions. Okay, now let's see the low latency solution. Low latency solution normally we use maybe for the TV studio or for the television centers. They require a very, very low latency about the live show. So basically, currently, NovaStar, we recommend the mode when you're using for this project is M Control 606 Pro and M Control 4K. And for the receiving card side, we also have a specific mode you need to use AHS or ATNS Plus. These two sending card and the receiving card work together, you can realize the low latency mode. So here is a comparison where we enable or disable the latency. So for general project, there will be 1 frame latency on the sending card part, and also there will be 2 frame latency on the receiving card part, because this two modes they all need to process the data. And also for the driver IC, we also have maybe 0 or 1 frame latency. Maybe you have some doubts. Why 0 to 1 frame? Because in this market, we may have too many ICs for the common IC. And the PWM IC. The PW is post with modulation. So if we use the PWM IC, it will cause 1 frame delay. If we use a common IC, there will be no delay on the screen side. So this is very important. Okay, so now let's have a summary. There is one frame delay on the sending card side, 2 frames on the receiving card side, and 0 to 1 frame delay on the driver IC side. So totally will be 3 to 4 frames. But if we enable the low latency on the sending card part, the sending card, this frame will goes to like 10 milliseconds. So basically it's close to 0 frame. And at the receiving card side, there's still 2 frames, and 0 to 1 frames is around 2 to 3 frame delay. If we enable the low latency both on sending card side and the receiving card side, we will have this kind of delay effect. So the sending card is close to 0 frame, and the receiving card side, we can reduce 1 frame delay. So it will be 1 frame. And the driver IC depends on its common IC and the PWM IC. So the total latency of the system will be around 2 frames, like 1 plus 1 or 2 plus 0. Now, here, please mention here. If we use a common IC, the receiving card cannot reduce the latency on itself. So it will be 1 plus. Thank you. It will be 1 plus 1 or 2 plus 0. So it's around 2 frames. Okay, now let's have summary. If we have this kind of requirements for the low latency project, we can use the ARM-Control 660 Pro, we can use ARM-Control 4K. And also we just mentioned the VX600, VX1000, and the Nova Pro UH Junior. We also support the low latency functions. So if you have this kind of requirement, you can just find out from this mode. Okay, next we will talk about the 3D solution, the HDR solution. The HDR is a high dynamic range. For some high-end requirements, they will have a really request on the image quality. So here is a demo system structure. The video source, we use the HDR10 video source, and it will be provided to ARM-Control 4K. So here, why? We use 2 pieces. As you can see here, the screen resolution is 4K. That's 4K. But so for ARM-Control 4K, it can hold the screen, right? But if we use the HDR solution, if we want to enable the HDR, we need to add another piece of ARM-Control 4K, because the HDR, it requires your video source input color depth, not 8-bit, it will be 10-bit. So if the video source input change to 10-bit, the loading capacity is now 650,000 pixels. It will be cut down by half. So this is very important. Tomorrow, Deacon will also explain this part for you. Okay, so for the HDR project, we need to use the ARM-Control 4K and the Nova Pro UHD Junior. And please note, the loading capacity of the sending controller will need cut down by half. So this is very important. And besides, we support HDR10, the HDR standard. We also support the HLG. If we have some other project which the source is from the HLG standard, we can also use the ARM-Control 4K and Nova Pro Junior. So this is about the HDR solution. So now let's talk about the 3D solution. The 3D we have the 3D we have the basic structure like this. The signal, the video source from the control PC, then provide to the ARM-Control 4K. The ARM-Control 4K load the screen, and we also need a EMT200. It will give out the signal to the shutter 3D glasses. And here is also very important for the 3D project. It's not about the video. It's not about the video source color depth. It's about the frame rate of the whole system. The 3D is just like the left eye video source and right eye video source. It will be overlapped together. So the system frame will increase to 120 hertz. So the system structure, so the loading capacity will also cut down by half. So you just need to remember for the HDR project, for the 3D project, the sending controller loading capacity will be cut down by half. And if we want to use like this kind of project, we need to select the VX1000, Nova Pro UD Junior, and M24K. They all support 3D solutions. I believe nowadays you may saw a lot of naked eye 3D, right? Let's see a video together. Because in the past 2 years, there is a lot of naked eye 3D LED screen all over China. Maybe you're still wondering, okay, for this kind of naked eye project, do we need some extra sending controller or some other device? No, totally no. Because for the naked 3D eye project, it mainly have some requirements for the video source. It uses the principle of the perspective, and it would deceive human eyes to like you generate the 3D effect. Basically, as long as we can create this kind of video source, we just display it on the LED screen. Especially if there is an angle, the effect will be much better. So for the 3D project, NovaStar will also have a professional team to do this kind of video source. If you have this kind of requirement, you can just talk to our support team or talk to our sales. We can just to make or produce this video source for you. Okay, the last part we will talk about is a fiber solution. Sorry. So when we need to use the fiber solution, as we know, for the Ethernet cable, the recommended transmit distance is within 100 meters, right? But if there is a screen, like in the football stadium, the control room and the screen is over 100 meters. If we use the Ethernet cable, it's not that stable because it cannot transmit that far. So we need to use the fiber solutions like this. Normally, the fiber converter, they use a pair of it. So one for transmit the Ethernet cable to the fiber cable. Then we go to another one, could be the receiver. Then we transmit the fiber signal to the Ethernet signal. Then we go to the screen. This is the structure. And actually, for currently, NovaStar, we have two. It can be two categories. Like we have 1.24G fiber, and we also have the 10G fiber. It's determined by the fiber module. And the CVT310, it's a multi-mode, which the transmit distance is within 300, and the CVT320 is a single mode. The maximum transmit distance goes to 10 kilometers. And the 10G fiber, we now have two modes. One is CVT10, and another is CVT4K. So now we will see a system structure together. So for example, now we have a 4K 1K screen, right? We need to use at least 8 output ports to load the screen. So here, I use a VX1000 as a sending controller, and I use port 1, port 2, port 8 to load the screen. And if we use a 1.2 G fiber solutions, then we need to one for receiving, one for sending, and this will be used for every output ports. So totally, let's take a look about this structure. Very complex, right? And let's say an atom list. So there will be one control PC and one sending controller. We use the VX1000 and a fabric converter. We need 8 output ports and one for receiving, one for sending. So totally we need 16 pieces. And for the Ethernet cable, the sending part, the receiving part, so totally also 16 cables. If we want to do the backup, so it will be 32 pieces of the Ethernet cable. And for the fabric cable, each channel we need a fabric cable, right? So totally here we need 8 fabric cable to transmit all the data. And for the power cable, you know here, every fabric converter we need to provide the power independently. So totally here we need 17 pieces for 16 fabric converter and also one for the sending part. And as we know, when we add one device into the control system, there will be more potential risk for the LED control system. For example, the power supply, the Ethernet to the fiber, for example, the sending port and all the receiving port, it all can be the potential risk. So for the LED control system, if we can simplify the system will be much stabler. Okay, now let's have a short summary about the CVT10 and CVT20. CVT10 is multi-mode and up to 300 meters. And CVT20 is single mode, is up to 10 kilometers. And the interface tab is all LC. And the fiber module, there's no need to remember that. You can just take a picture or make a screenshot. And if you have this kind of requirement, you can just ask our technicians. They will give you the right choice. And this will be the control room if we use a 1.25G fiber solutions. All the sending card here and all the fiber cables here and all these net cables here. And then we need to mark numbers on it. Otherwise, maybe we'll be confused when we do the configuration. So it will be multiple devices, lots of cables, and it will take a lot of spaces and difficult to maintain, and will reduce the reliability of the whole control system. Now, what if we use 10G fiber solutions, like the CVT4K or CVT10? For example, the CVT4K, some of you may have already used this in the project. The CVT4K always used together with AMP control 4K. It will have the Ethernet con and power con fiber backup and hot swap. So here, as you can see, we have the blue color and the green color. Each optic fiber supports to transmit 8 Ethernet cable output ports. And we have the master channel, and we also have the backup channel. So totally, with one piece CVT4K, we can support to converter of 4K screen resolution data. So the sending card, we can use AMP control 4K, and the receiving card, and the fiber converter, we can use the CVT4K. The structure will be like this. AMP control 4K, right? We can use the fiber, 2 fibers, OPD1 for the port 1 to 8 and OPD2 for the port 9 to 16. Then we go to the CVT4K. And CVT4K, we use Ethernet cable to connect the screen 1 to 16. So totally structure would be like this. So it's simplified a lot, right? We do not have to use like many pieces, 16, maybe 16 fabric converters. We just need one. And for the CVT4K, we also have the multi-mode and the single mode. The multi-mode, you just remember, multi-mode up to 600 and the single mode up to 10 kilometers. And the fiber ports, we have 4, 2 for primary and 2 for backup. And the Ethernet ports is, we have 16 for the 4K screen. Normally the CVT4K used together with AMP control 4K. And here is the same with the CVT10 and CVT20, the LC type, and the fiber mode, you just take a picture. Okay, we also have another fiber converter which released just recent year, named as CVT10. As you can see here, we have 10 Ethernet cable output ports And we also have 2 OPT ports. Here, one OPT can support to transmit 10 channels Ethernet ports. So for example, if we have structure like this, still the 4K 1K screen light. In the traditional way, or the 1.25G solutions, we use 8 channels. We use 16 fabric converters, but now we just use 2 of the CVT10, one for sending and one for receiving. So the cables will be reduced a lot, and the system structure will be simplified a lot. And here is the CVT4K work together with the CVT10. As you can see here, even though the CVT4K we have the 10 output ports, but if it used together with uncontrolled 4K, we need at least 2 pieces of it, right? So at that time, each CVT10 will transmit 8 output ports, similar with the CVT4K. So here, the 1 to 8 will correspondingly to the 1 to 8. This 1 to 8 will correspondingly to the 9 to 16. It will be like this. We still have a short summary. Multi-mode, 300 meters, single mode up to 10 kilometers, and 1 primary and 1 for backup. And we have 10 output ports. This is the same with the CVT4K and also with the CVT10 or CVT20. You can just take a picture. And here is also a comparison about the CVT10 and CVT4K. You can just take a picture. Okay, now I will give you a selection guide. So because we have a lot of fabric converters, so which project we need to use which one? So here is a recommend. If we have a project, the sending controller, we use a VX4S, VX16, VX600, VX300, R5, 660. We can just use a CVT 310 or 320. This is a 1.25G solutions. And we can also choose the CVT10. These are 10G fabric solutions. And if we use uncontrolled 4K, Nova Pro UHD Junior, and also on the Wednesday, we'll talk about the H series. We can also work together with the CVT4K. If we use the VX1000 and H series with 20 RG5 sending card, we can use the CVT10. This is a recommend. This is a recommend. You can. So when you have a project, if you use 4K, okay, CVT4K. If we have a project, we use H series or VX1000, CVT10 is recommended. So just remember this. Okay, here is a selection get, but please remember here, the fabric converter, the SFP modules and the fabric converter always working in pair. No matter it's CVT10 or CVT 310 or 320, we need to be one for sending, one for receiving. But if there are some other structures, we can just use one. Yes, because we have some sending controllers, we have different mode, right? In the previous pages, we mentioned about the fiber converter mode here. Here, for the 300 or 660 VX4S or the H series sender card, we need a pair of the converters are needed. But if we use like Control 660 Pro or VX1000 or Nova Pro UHD Junior, we can just use this as the sending controller, and we just use one to be the fabric converter is enough because they already have the fabric outputs on itself. So we just need one for the receiver and to load the screen. Okay, basically this is all the content for today, and let's have a short summary. We just talked about the basic structure of LED control system, and also we talked about the product line and the product evolution, and we checked the different production for different scenarios like 3D, 4K, HDR low latency, and the fabric solutions. Okay, if you have any questions related to today's content, you can just type your questions into the chat room.